Welcome back, electronic fans, to LeilaniElectronics.com. Before we get started, like and subscribe to the channel. Go to the website, LeilaniElectronics.com. Print out these amazing schematics and circuits. Get some programs, some other information. So what we have here is two circuits using the LM34 temperature sensor. One circuit uses a microcontroller, which is surface mount, for all you people that like the program like me, and one's just a regular through-hole circuit that doesn't require any programming for, some people don't, wish to program or have to, deal with the programming. So you can breadboard both of these. The first one we're going to get into just uses standard through-hole components, so you can get the temperature that way, or go through surface mount and program your chip. The first one uses the I think it's the ICL7107, yeah, and it has the drivers and all the circuitry built in. You just provide analog voltage on the input. So the LM34 gives you 10 millivolts per degree. So if you're reading 60 millivolts, you probably be getting, you should be getting about 60 degrees. So if my math is right, 10 millivolts times 60, yeah, about 60 degrees. So we're going to turn this on. Well, first we're going to turn on the surface mount, which uses an OLED display, and built into it I have a RTC, which is a real-time clock, so you can get the temperature of wherever you're at plus the time. It's just something extra I threw it on the circuit just because I had the space. But right now I'm in my garage on my test bench, and it's kind of cold because it's cold outside, so it was reading like 60 degrees. So let's turn this on. There you have it. Now once you turn it on, the chip is just going to start the date from 12/24. That's what I have a program for. But and then it'll start taking the temperature. Right now it's saying 56. Now if you grab this LM34 and squeeze it to get it warm, see how the temperature went up to 60, 63? And then it'll drop back once it gets cooler. See if we can get a good look at that. There you go. Okay, we're going to turn this off. We're going to plug in the other one. There's plugged in. See, it immediately went to 60. And here's the LM34 down here. I've been using this chip for years. It's really good. See how when you hold it and get it heated, it gets warm. So I got my meter out. We're going to check the output. And there's also a trimmer pot so you can adjust it. Once it settles down and gets to its temperature, I'll rotate that and you'll see how it goes. You can, fine tune it. Okay, it's about 62.2. See if I turn it, 50. Get it back to 62. Okay, there we go. Okay, so we got our digital voltmeter right here. Let's see if I can put it on you guys. There you go. I'm going to ground this and go on the output pin. See, 0.60. So it's about 60 degrees in here. So now I know what the actual temperature is. I can go over to this and adjust it. Yeah, right there. Now we got an accurate reading of where I'm sitting at in my garage on my test bench. Okay, now I'm going to get over to the schematics, which you can go to the website, print them out. You can build this circuit. Okay, here's a circuit for the through-hole, non-surface mount, non-programming. You can build this. It uses two 2-digit displays, the common anode. You have your drop. I use these diodes to drop the voltage down to about, I think it's 2.8. You don't want to put 5 volts right on there. Here's your power supply. It all works from 5 volts. This circuit's pretty easy. You just build it together. There's your input. There's your LM34. It requires its own power supply for this particular circuit. And that's it. Now we'll go over to the microcontrolled circuit. Okay, there you go. Okay, right here we have the OLED, the 128 by 64. And the OLED requires its own power supply. So you have to have a power supply with an enable and a disable, because again, OLEDs have to be powered up and initialized in sequence and powered down in sequence. So you have to be careful because you can damage it. And over the years of working with OLEDs, over the last 15 years, I've burned up a couple. It happens, but you got to be careful when you initialize them and put power on them and know when to turn the power off. You can't just unplug it. You have to send a code, say turn off, wait, normally it's like 10 milliseconds, wait for the screen to do its thing, and then you can remove the power. Here's your DS1302 real-time clock. Here's your PIC 16F88, and here's your A to D converter. Here's your LM34 and your power supply. Since the LM34 gives you an analog voltage, this 10-bit ADC converts that to a digital a 10-bit code that the microchip reads, and it's converts it, and then it talks to the OLED. Fairly simple. Power supply, RTC, A to D converter, PIC, and your LM, and your standard power supply, 5 volt. And that's it. Hope you like it. Go over to the website. You can print these out. I'm going to put the parts lists up, and maybe put the program up soon. Right now I just got the schematics and the parts list, but I'll get the program for this one up soon. LeilaniElectronics.com. Hope you like it. Like and subscribe. Take care.